Now we're looking at the last of the types of conics, parabolas, which of course is the one that you're most familiar with from last year. And there are two forms of the equation, as with all the conics: the standard form, looking very much like you're used to, and the parametric form. Both assume, of course, that the vertex, that is the point of the parabola, occurs at the origin, and for this year you'll notice that it assumes that the parabola is heading out to infinity in the x dimension rather than the y, that it is rotated 90 degrees round from previous years. That's why y squared equals some function of x, not x as some function of y squared. The shifts now, instead of occurring on the center, because the parabola doesn't have a center, are applied to the vertex. Wherever that turning point is on the parabola, that is what we use to shift it in the x and the y direction. We need to find the vertex before we can find anything else. In the case of the other conics, it was the center and not the corners, not the vertices. This time it's the vertex. And added as a complication from last year is we, instead of writing some constant, we write 4 times a, where a is the focal length of the parabola, and that applies both in this form and in both versions of the parametric form. You need to know the focal length to write the parametric version. It is the distance from the vertex to the focus. When we rotate it 90 degrees to the previous way, then we swap the x and the y. Y squared equals 4ax becomes x squared equals 4ay, and the two versions, the parametric versions, swap as well. And we're used to this version as y is some constant of x. That's the version we've always used in the past. This time it just happens to be that the constant is 1 over 4 times the focal length. So if we have any 3 points, can we write a parabola? Well, yes we can, and we can't do it in the parametric form. It's a bit too complicated. We instead will use the other form. So if we have points 3, 8 and minus 1, 5, and we're told that minus 1, 5 is the vertex, then we can go pretty much straight to writing our equation, because the vertex means that we have the x and the y shift straight away, and that leaves us with only one of the parameters left to go, that is the 4a, but we know that for a y of 8 we get an x of 3, so we can substitute a y of 8 for an x of 3, and this must be true. We solve that, 9 and 16a, so a must be 9 over 16.5625, and we can substitute that value in, 4 times it into our equation, and there we have our equation for a parabola. Very simple once we have that vertex. If we have 2 points like this, then they are on the same vertical line, but we can't pin which of the various parabolas it is from 2 points until we're given another piece of information. Now we might be given a third point, or we might be given a vertex, but another thing we might be told is we might be told that there's a focal length of 1, and that actually is all the information we need, because in our equations we have x and y shifts and the focal length. So we're going to substitute in what we know. We know the focal length is 1, so the a is 1, so that gets rid of that parameter, and we can use symmetry because the perpendicular bisector of 2 points on opposite sides will run through the vertex. So we don't know what the vertex is, but we do know that its y value is 5, because this is the line y is equal to 5, halfway between 2 and 8. So we substitute y is equal to 5, y minus 5 rather, equals 4x minus b. Now we've got everything except a b, but we can substitute a point in. We'll substitute in for 8. For a y of 8, we have an x of 4, and we can solve pretty quickly from there. So b is 1.75, and that enables us to write our equation. So if you're given the vertex, then things are pretty quick. It gives you your x and y shift, and you can pretty quickly substitute a point in to find the last remaining parameters. If you're not given the vertex, then you need to be given some piece of other information that enables you to calculate it. If you're given 3 random points, such as this, then it is in fact possible to work out the parabola that goes through them, but it isn't really a conics question. Instead of using the conics form, we use the standard form, which is the expanded version, and we substitute our values in to the equation. So 3, 7, so 7 squared, this is the form here, a times 7 squared plus b times 7 plus c equals x, and x is equal to 3. That generates this one, this point generates this one, and this point generates this one. And that we can solve on our graphics calculator, 3x3 equation, and it gives us this value here. You won't actually be asked that because it's not really a conics question. The conics questions will involve some knowledge of a parabola, be it symmetry or focal length, but they won't involve straight out algebra.